Hello, world. Two simple words that most of us, all of us, I would say, have found ourselves at one point in time in one incantation or another uttering or typing in multitudes of languages, trying to be able to learn and comprehend some sort of new complex system. It's kind of a peaceful way for us to start thinking about our new journey that we're going to take into some sort of unknown landscape. And while that journey starts out with great expectations, sometimes things just don't quite go the way that you planned. And it's strange that this thing that we feel should be so simple, these two simple words that we start with, can just lead us to a place of pure frustration. And the really curious part about it is that we kind of feel that this day and age, these things should be a little bit more simple than this, that saying something into a box and just trying to get it to echo it back to us should be something that should primarily, as a first step, be an easier task to accomplish. And then what we find is, just like that, it all just kind of works. And oh, look at that, it was a typo. And we go on our way, not thinking about what it was that we just experienced and the thing that we just did. And it's kind of a curious thing, because in order to truly say hello to the world, you really need to start by inventing the world. What I want to do today is I want to take a moment to peel back the covers a little bit and sort of shine a light on all of these areas of our lives as programmers and engineers, and just point out areas that I believe we've taken for granted. Because even though this is just text on a screen, in order for us to truly understand the complexity, we need to realize that in order for us to say hello world on a display, we need to do fonts. We need to understand how to rasterize them. We need to understand how displays work. We need to understand how to just break things down and start from the beginning and turn on a single light. The similarities that I want to make are those that will allow us to be able to think a little bit more freely when it comes to approaching things that seem unapproachable, when it comes to encountering technology and stacks and other kinds of ways of constructing things, front-end development, back-end development, hardware. And I want to make it a little less scary, because just since we don't know something, since we don't understand how something works, doesn't mean that we can't draw some similarities to our own experiences. And so in the beginning, if we were to deconstruct hello world, then what would it mean? Well, in order for us to light up those pixels that let us render that text to that display, we need to turn on a single light. And in hardware, this is our hello world. When we develop hardware systems, we may see symbols like this. And this might be strange and new. This here is a schematic symbol for the light. What we have is positive energy on one side, negative energy on the other side. The power is flowing across this light emitting diode, this LED. And as the power goes across this LED, it illuminates. And the interesting bit here is that what we're doing is we're setting up a logical circuit. We're setting up a a bit of transformation. In the case of software engineering, we're used to transformation of data all the time. And if we think about what data is, it's really just an encoding of ones and zeros, or positive energy and negative. Is it high? Is it low? Is there voltage? Is there not voltage? Ones, zeros. And in the case of this symbol right here, all we're doing is we're transforming electricity into light. Now, when we do things correctly, we expect great positive results. When we type in hello world, we expect to see hello world back, but the world doesn't act that way all the time. And so even in new realms like hardware, if you're not familiar or if you've been there forever, when you break a circuit, it truly will break. In this case, if we were to apply way too much voltage or way too much current to our electrical design, that LED might not be able to handle it. That light will just vanish. In my case, in this circuit, I forgot to put a fundamental component. In this case, this is a resistor that's been added to try to just be able to, this is a crucial element that you add into LED circuitry. And now, once we get to this place, we can feel that moment of success. This is like getting that rush back, you know, but getting there is not without its frustrations, just like we see in software development. Here is a prime example. As you can tell, I've printed 2 of those boards, and one of them makes for a pretty good whiskey coaster at this point. And that's because when I wired the first one, I wired it backwards, not just backwards from voltage. In the case of a normal LED light, that might be fine. But in this case, these are 3-color LED lights that have a little bit of intelligent circuitry inside of them. And when you wire them backwards, they kind of erupt in a sort of fireworks display. And the scary part about this might just be that we're not familiar with how to cope with problems. In the case of hardware, there is no Control-Z that we can hit to get ourselves out of a problem. Control-Z in this case is, let's just print a new one. But if you get something out in the field, how do you fix it or update it? Well, that looks a little bit like this. In this case, what we're seeing is we've had an issue where one of the parts was improperly connected electrically, and we needed to be able to solve that. Now, for scale, you might not truly appreciate this size, but that wire there is 30 gauge. That's very thin and almost near impossible to be able to solder with the naked eye. This had to be done under a microscope, which was how this picture was taken. You see, when we finally get something that works, in electrical senses, what we do is we draw a box around it. We build that into a component. And then we can say, we know that this works in practice. This component's proper. As long as the data comes in this side, everything's good. As long as we connect these electrically externally, everything is going to be good. And in this case, this is a very simple component. It might even be an absurd component. But as complexity grows, much like in software, as does it in hardware, components have become more complicated, and they contain a variety of different helpful pieces of circuitry. They have lots of different inputs and outputs on them. This is an integrated circuit or IC component, and this might do any number of different transformations. It might also expect there to be a software stack that lives on top of it. And so what do we find ourselves doing in this case with hardware? These components, they're nothing more than dependencies. Just as we have hardware dependencies, we have software dependencies, and oftentimes in the case where we build these IoT platforms, they coexist. So much so that there is a very one-to-one relationship with a lot of them. That's what would be called a driver. And this might start to then hopefully make hardware more approachable. Because really, I think that one of the problems that we face as developers is that when we see these different areas that we're not familiar with, we have a hard time trying to be able to take from our own experience and apply it to this new domain without any knowledge whatsoever. And what we find ourselves doing is we end up sort of just thinking that this new thing that we're unknown about is infallible, that it's somehow void of all of the kinds of mistakes that we would make, that people before us have gotten it right, that the documentation was correct, or that all of it was ended up tested with all kinds of different interactions. And I think that this is a big mistake that we find ourselves in. When we make these assumptions, we end up losing out on a lot of the skills that we have gained over the years on how to adapt to problems and what to do when we're faced with these challenges. And so my journey through understanding more about hardware and how it relates to software development has sort of led me to the understanding then that, similar to how we have dependencies in software, not only is the dependency, the purpose that that dependency was built for, important, but equal to that, if not more, is how the external world is to interface with that component, with that dependency. And there's a lot of choices out there for how you select components in your hardware designs, which ones you might choose. And often that's driven by different metrics than we would choose for a software perspective. We might look for something that's easy to interface with, whereas an electrical engineer may look for something that will reduce the cost of the board overall. And that might be a pitfall, because we might end up, in one hand, selecting a part that will cost more in the long run, because the software that can run on it is a lot more kludgy than the other chip that might be available, which upfront costs a little bit more. But the reality is that the software has got a little bit more support to it. Documentation is a little bit better, and it might be a little bit easier to reason about. And so now that we have this relationship, I want to sort of start to shine a light about. We all know in software dependencies how important it is for us to minimize the amount of software dependencies we have. And in the case of nerves, we promote this heavily. You know, we promote the idea that you should create reasonable systems with small firmware sizes. And how we do that is we give you an opt-in approach. We let you ship from a software perspective only what you need. And on top of that, we give you the ability to do fault-tolerant and robust updates. But when you're thinking about dependencies when it comes to hardware, you kind of need to be able to make a lot of these decisions up front. Because even though hardware is very much so in ways analogous to software development, the reality is that it's software that's cast in stone, in sand. And you kind of need to make these decisions up front, because you're not going to send somebody out into the field to solder tiny wires or add components to a board that was missing them in the first place. And most oftentimes, the reason that we find this bites us is because we don't let these teams, or we don't encourage these teams to cross-communicate. And oftentimes we'll see the mentality that hardware engineering needs to be able to be solidified completely up front before software engineering even gets a chance to look at things. And I think that that's the wrong way to go about it. And for lack of a better term, I kind of want to start to say that we should address the agility that hardware is lacking. And a prime example of this is to say, we get our hardware manufactured and we realize that we want to be able to connect to the internet, and we want to be able to do it securely. And we might not have made this realization that hardware dependency needs until after we've already started to then receive boards back from manufacturing, or And we're starting to now build our software stacks out. So one of these is a hardware security module. This is an important addition to your board. It's on the matter of sense to be able to add. And what this does is it allows you to be able to delegate a lot of the public key infrastructure, the private keys that you would need to provide to a server to validate your identity. This piece of hardware needs to be added to a board so that you can securely communicate with servers. And you're not going to, so this is a decision that would have to be made up front. So it's very important during these times to be able to consider this early. And now dependencies aren't all bad, right? We have to have dependencies. Otherwise, we would just continually be reinventing the world. And so, yes, I understand that there's a level of absurdity to saying that it's all bad. It's not all bad, but too much can be bad because really when we understand it from a software perspective, we know that if we buy in too much, if we take on too much dependency that's unknown to us, then we might unnecessarily open ourselves up to software vulnerabilities. And I argue the fact that as the complexity in dependencies or components in hardware increases, as the amount of functionality gets packed into them, that majority maybe of which we won't need or exercise, as that scale increases, we too there have a similar situation, a similar problem in that from a hardware perspective, we will also be subject to the same vulnerabilities. And so understand your dependencies and select them wisely. Now, over the course of the last year or 2 years, we've ended up shipping the 1.0, long time ago, 2.5 years ago or so, we shipped a stable version of the NERVS compiler. And a lot of us got to work on building a lot of our projects out and started to be able to create these IoT products using NERVS. And so we started shifting our mindset more towards making it approachable for the runtime. And that includes offering a set of convenient dependencies that you can start to leverage and layer in small reusable fashion to be able to help bootstrap your projects. A large effort of this has been pushed forward by Frank Hunleth and John Karstens and the rest of the team at SmartRent. And SmartRent is a smart home rental platform that allows rental management companies to be able to manage properties using smart home automation technology. And they have a need to build out devices using NERVS. And so Frank has been leading the charge to help build out our networking stack. This has been a primary huge push that SmartRent has pushed forward. Now, one of the other things, since this is about taking things for granted, is with NERVS devices, most developers would expect or anticipate when they start up their Elixir or Erlang node that the network would be available. And in our case with NERVS, it's up to you to start the network. And that's because, as we mentioned, hardware has a lot of software dependencies or specific drivers to be able to get them working. And because NERVS can operate on a multitude of targets, these allow us to be able to abstract that layer away and give you ways to be able to connect using different mechanisms. For example, NERVS networking contains a full stack of connectivity for Ethernet, USB, and Wi-Fi. It also includes cellular connectivity and captive portal. So to break this down a little bit more, we've in the past had a lot of answers for shipping Ethernet USB devices. We've expanded our capabilities for shipping Wi-Fi. And new this year, we've started adding in a lot of support for VintageNet Mobile, which is for cellular connectivity. If you're interested in building devices that speak over cellular, I recommend that you take a look at the VintageNet Mobile repository on NERVS networking on the GitHub org and take a peek to see how it operates under the hood. There is a variety of modems that are already supported out of the box, and you can pick one of those up and start playing with it. But adding support for additional modems is encouraged, and there's also an abstraction that allows us to be able to hook your modem code into the main stack in this case. In addition, SmartRen has been working on smart home connected devices, and so they have a huge need to be able to communicate using some different wireless frequencies. They also have created the Grizzly package, which is for communicating with Z-Wave devices. These are tiny embedded devices that would live in like smart door locks and door sensors, things of that nature. And they also have recently taken a push to spruce up some of the work on the Bluetooth stack, and that project is listed there on the left. That's Blue Heron. You can also check these out at SmartRent's GitHub organization as well. For connecting and talking to a lot of hardware components, we often find ourselves working with a variety of different terms and different communication mechanisms than what we're used to. What we might be used to seeing as far as connectivity of Wi-Fi and Ethernet, network connectivity, high-speed connectivity, long-range WAN connectivity, doesn't really apply when it comes to communicating with sensors or different kinds of circuits that might exist on your board. And that's what the Elixir Circuits project is working to be able to solve as well. Elixir Circuits contains a variety of different helpful libraries, like GPIO connectivity, and that's for communicating easily with buttons or switches, lights. And we also have the I2C library that helps us work with other sensors like accelerometers or gyroscopes, compasses of that nature. SPI, which is another kind of interface, and that allows us to be able to work with common analog to digital converters. You might want to measure voltage, or you might have analog joystick that you need to know exact precise positionings of. It's also useful for communicating with small displays, LCD displays and such. And also UART, which is another word for a serial port connection. The Circuits UART is used a lot in the VintageNet Mobile library as well to be able to communicate with cellular modems. You'll also find that as a common way to be able to communicate with Bluetooth devices and GPS receivers. Now, one of the biggest advantages that we have with nerves and using it to be able to develop embedded systems is not just these pieces, these dependencies that we have created to make it easier to interface with hardware, but you also have access to the vast plethora of packages that you have on Hex and that you can find for Elixir, Erlang. But because we run embedded Linux, you can also include additional user dependencies such as C or Rust, Go, Python. Really, it's anything that you could package onto a desktop Linux system, you could likely package and away on your embedded Linux nerves runtime as well. Similarly, at Very, we've been working on sort of an additional aspect to this. The community and Frank's teams have been pushing forward on creating a lot of wonderful dependencies that can be shared and used. What happened was I joined Very in the beginning of this year as a software engineering fellow. And my goal has been to figure out ways that we can take the lessons that we've learned from nerves. Now, before my time there, I should mention that Very was already using nerves, and they were using it to ship embedded products they've been working on before that. And so they have had experience in this domain. And a lot of the teams felt freed by the ability with nerves to run on your host and not always having to force you to run on an embedded device or on a target, as we would say. That flexibility kind of gives you the ways of iterating a lot faster, right? And so my task, my goals with the company, the organization, have been to try to take what we've learned and stripping back dependencies, shipping minimal systems, and applying that not only to the software engineering portions of things, but also to apply that mentality to a team perspective, to hardware. Because traditionally, with how these projects would flow is more like a waterfall design, where hardware engineering would start developing a board, and then they would give that to the firmware engineers, and they'd create something that'll work on top of it, and then finally people can use that to be able to connect to servers, and then eventually that server stuff gets connected to the web and the mobile devices. And I think in this scenario, it's we've seen this before, where this would be analogous to saying that in these situations, the front end people don't really talk to the back end people because they're separate teams, and they may be given different tasks, and that in the end, they just have to work together at the seams that would be represented by those arrows to integrate it eventually. And usually those are moments that are met with a lot of pain. The approach that we take in this case is to try to stack a lot of this work up together so that we can, at the same time, collaboratively walk through a process towards creating an IoT product as a final result. And that all of us together will sort of let the experiences and the expertise that we have in each one of our domains blend across to neighbors, where firmware will work closely with hardware in early stages so that we can better set ourselves up to have success when we receive the boards back for the first time. What we'll do is from firmware's perspective, we'll create firmware right away that deploys minimal code that gives us a place where we can start to iterate on, that lets us exercise simulations on the host. And these simulators may be able to get exposed all the way up through to the server level so that the backend engineers, the server engineers, can focus on integrating information that comes back from these simulated devices early. And then they can allow mobile application developers or web front-end developers to be able to be free to start to integrate as well against this kind of data. Getting this pipeline flowing is so important, because the moments that you work to integrate those APIs, if you would consider ourselves as teams to be components, the APIs that we use to communicate with each other are equal to or more important than what we're internally doing on our own. Another effort that has been going on at Very. Very's been investing a lot of time and energy into nerves as far as adoption is concerned, because from our perspective, from a consultancy's position, we have a unique perspective into the development life cycle. And so while there's other companies that are creating, such as SmartRen and others, that are creating lots of IP or dependencies that are very helpful and useful and wonderfully made wonderfully available to the community and support, our efforts have been focused in adoption, because we can see into this life cycle of creating products at a rate that's faster or more frequent than a single product company. See, a product company will go through that development life cycle, and then when they reach the end, they've essentially been left with what you could refer to as the devil that you know. And in those cases, you may forget about some of the pain that you had to work around in the experience of bootstrapping this project or getting some little quirky, finicky thing to work. And from our perspective, we believe that onboarding into new projects, since we do it so frequently with new IoT products coming through the pipeline. We are trying to focus a lot of our time and energy on the appearances, making it easier to integrate, and also making it easier to be able to develop on your host. And where we started with this was to just try to be able to make nerves more approachable. Some of you may remember our website looking a lot like this, and our logo, like as many pointed out, a jack. And so in the beginning of the year, very graciously put forward an effort to help us redesign our site and launch a new front end for promoting what it is that we stand for. It's a cleaner, more, beautiful look into case studies, and it's easier to read, easier to view. It's just a wonderful effort that's put forward there. Very happy with the output of this and the design. One of the problems that I've always sort of joked about over the years has been that as a bunch of backend or developer engineers, none of us really did a lot of web development, and it was funny that CVEs like Heartbleed and other websites would come out that like websites for these like exploits would look way beautiful and over the top, and we couldn't really we didn't have the ability to do that internally. So I want to thank so much for this work. It looks beautiful, but it didn't stop there. See, part of our tool set is to be able to not only help the customers coming into the system and developing their product, but once we develop the product, we put together the minimal amount of dependencies, we'll build the board and put it together, and then we'll go to ship that. We leverage Nerves Hub a lot to be able to keep those up to date in the field. So Nerves Hub is a firmware update and device management server. It's written in Elixir. It's open source, and it's a wonderful example of Phoenix operating in AWS with multiple services interconnected with Erlang distribution, and it also leverages LiveView to be able to update the user interfaces as well. And I am no web developer. I took a pass at the first level of Nerves Hub UIs, and this was what we were working with for a long period of time. Quite basic, quite simple. And over the course of the last year, we've been working to be able to make it more approachable and friendly to developers. And we're very close to launching the new version. So what I'd like to do today is I'd like to give you a little glimpse at what the new Nerves Hub is going to look like. And I'm waiting for, I'm listening to the virtual ooh. I can hear an ooh in my head of as if I was standing in Colorado and we're all speaking live. This here is the new Nerves Hub. It uses our new logo and our new color schemes, and it starts to portray information in ways that's more friendly and approachable than the previous versions. This here is the devices view. We can see we can have ones that are updating, we have error states, and we can also tell what groups they were coming from as well. Keep a lookout for this update. The UI refresh is on its way. Very excited about it. I'd like to also shine light on another feature that John Karstens from the SmartRent team has been working hard on, and that's the remote console. There was a massive update that went in place to our remote console. Any users who are using Nerves Hub may notice if they use the remote console that they got a deprecation warning telling them that the old version was deprecated. If you update your dependency for Nerves Hub link, you'll be able to use the new interactive console, which actually is very robust. It supports pretty much everything that we've thrown at it. It'll also do tab completion. It's full featured for sure. And it's just a joy to use because in this situation, this is all using Phoenix channels and protected using client-side SSL all the way down to the board, which is leveraging, which we would promote the use of leveraging the crypto authentication processors for such as Nerves Key to be able to secure these communications. And finally, one of the big features that we've been working on for Nerves Hub has been performing Delta updates. And Delta updates are important for many reasons. Those of you who may have heard me speak at Lone Star in the beginning of the year, I kind of had a little bit of a realization that that any devices that are connecting over cellular are kind of not in a good position to be able to receive even 30 megabyte firmware updates based off of the amount of money that is required to keep a fleet up to date of devices. That our incentives for these systems are pushed more towards consumer entertainment than they are keeping business devices and consumer devices secured. So it's paramount for us to be able to make sure that our security is ongoing and our software bugs can be patched, because that inevitably is, I believe, a responsibility for us to provide to somebody that's buying this product. They have a similar level of naivety and understanding and trusting that the people that they're buying it from actually have their best interests and security in mind. And so with Delta updates, the way it works is, instead of sending this whole payload, let's say our application consists of these 4 different sections, and then we go and make an update. In a naive update approach, we might look at this and just compare bit for bit. And what we'll do is we'll scan the sequence and we'll say the first bit, yep, that's good. We can send that. And then once we hit one that we don't understand, we'll go, nope, all the rest of this is different. Even though we clearly can see that only the purple section was added, it would think that the green, yellow, and orange sections were new because it doesn't understand that their positions are different, but their contents are similar. And so this doesn't really provide a very robust approach. And what we ended up landing on after reading many research papers on the topic was using XDelta, which is a common updating practice. And what it does is it has a look ahead and a look behind approach to being able to identify just the chunks that are different. It can then figure out which ones have similarities and understand from a binary patching perspective that it can shift pieces and send the smallest and most minimal portions for updating. And this allows us now to be able to build up our application, get it out there, and now keep it up to date, even if we're using cellular connectivity. I would love to be able to tell you as well that this feature, most of the time you'll find lots of services are, if they offer this capability, it's quite expensive. And we believe so wholeheartedly in trying to be able to shift the mindset of security for people that this will be in the open source version of Nerves as well, and Nerves Hub. So here we are. We can ship our stuff into production. And what did we learn about this experience? Well, I believe that in order for us to be able to make changes for the better, we need to start to let go of some of the fuzziness that we hold, that some of the naivety that we have towards the complexity in the things that we're doing. For example, when we try to be able to build something from the beginning, we're already standing on the shoulders of giants. And we have to appreciate that, because wherever that giant moves, we have to move too, or we'll be left behind. And so it's truly important for us to understand our dependencies and realize what it is that we actually need and minimize that dependency in both hardware and software. And to do that, it's going to require us to be able to reach across teams, for us to have more open communication with each other, so that our own APIs become the most important part of our experiences, so that we can share that information, so we can identify pitfalls before they end up getting transitioned over to our group. I also believe that it's important and crucial for us to mock and simulate target-specific dependencies, because that's going to help our teams operate and iterate faster without having to be bound by hardware. And most importantly, that everybody is always saying, always integrate early, often, always integrate, because if you wait too long, it will just be painful. So all of these things together are going to get us to a place where we can build these kinds of IoT products faster. And I think that it's important that we consider these things, because if we let ourselves shroud the idea of what's behind the curtain, the complexity, what's going to end up happening is what's happened before with software, is that we're going to encounter more times where we're pressured to ship the breadboard. And that's only because what the people that are looking at that don't see it as a breadboard. But the reality is that it is, and it needs to be crafted in a way that's responsible. And so all of these things together allow us to be able to say, hello, world. Thanks.
Thank you very much, Justin. I think we have time for questions. There's a couple of them.
Let me exit here. Yes. So great talk, thank you. The dashboards seem useful when you have few devices. What are you planning for large amounts of devices? Good question. For large amounts of devices, we're working towards implementing device filtering that'll allow us to be able to create filtered views of certain search terms, including devices that are in certain tag groups, or devices that are quarantined, or in that term, not able to connect because there's an issue with them, or they failed to update for a long period of time. And I think that in those cases, that's going to help us get better introspection into them. We are actively working on making those views more useful, and I anticipate and embrace the idea of large amounts of devices. I'd also like to be able to make mention in this case that the servers that are available for us to use, the open source version of Nerves Hub, there's a hosted instance at nerves-hub.org. And as we roll out this, as we roll out the user interface updates, we'll be opening that up for more people to be able to freely sign up. We will encourage that people who are using Nerves Hub for commercial purposes, and who would like to be able to use a hosted instance that's not self-hosted, keep an eye on Very and our blog. We're going to be launching another instance of Nerves Hub that's going to be dedicated and geared towards commercial users for scaling out, and also for offering long-term support contracts as well, so that we can help maintain that stack for the long run. Thank you to our open source, Open Collective sponsors, that's it. They are responsible for helping to fund a lot of the servers that we stand up to be able to keep nerves-hub.org operational. So keep an eye out for that, and thank you for the support. Another one. Somebody knows Mike Simpson, who used to work at Very. Exciting, yes. We are hiring as well, so it would be great to be able to have people come and check us out. And if you're interested in participating in this sort of agile hardware revolution that we're trying to be able to stir up, we'd love to be able to have a conversation with you. How would a software person get into IoT? I've always had an interest in hardware, but I'm not sure where to start. That is a fantastic question. And, you know, I feel like I've done disjustice to people in the past, where I would say, you have to just find something that you're interested in and try to automate it. As sort of like apropos as that might be, the reality of it is that oftentimes those people don't know how to start small. And so they'll be like, oh, I want to build a rocket ship. And while that's an advantageous path to be able to go down, and I would not stop anybody from doing so, I think that they might set themselves up for a little bit of failure. And so what I end up advocating at this point is to just to start getting familiar with hardware, you have to feel comfortable with it. And so Blinky, or lighting up an LED, is the easiest and first place to start. And then from there, I would say, try to use that, how to turn on an LED and turn it off, to build maybe an automated device for your home to turn on something around your home and turn it off, because that will allow you then to explore connectivity of the device, and implementing maybe some features that you might have more familiarity with, like Phoenix, or the web-driven end of it, in that nature. And it looks like we have another one here. Talked about interoperability. How powerful could that be running C, like machine learning or computer vision? Also a great question. I believe that, well, so with nerves, I've sort of recently started embracing the idea that we have this platform, because we run on embedded Linux, that we say, bring your own code. And that we're really good at control plane. The Erlang process model is a great way for us to be able to sort of isolate the explosions that could happen and supervise some of the things that are unsupervised generally. And one way that this occurs is if you have some C code that you might want to run, you might use Erlang or Elixir in that case to be able to supervise that process via a port, or if you want to live a little bit more dangerously, a NIF. If you want to be safer with it, you can use Rust or Go or something like that in your NIF and try to be able to isolate some of the explosion there. But the idea being that the computer power, the computational power of the platform that you're running on is only bound by the CPU and the hardware specifications that you've put out there. The Raspberry Pi and other single board computers that you can buy available off the shelf, including x86 hardware that's become available, is quite powerful these days. And so I would say that if there's a C library or some sort of ancillary code that's native compiled that you want to be able to try with it, you should have a lot of the same resources available to it as you would without running nerves. And that the Erlang VM will act as a scheduler and monitor on top of it. So therefore, you'd still get a high level of performance, and you'd still get the connectivity benefits and interoperability benefits of the higher level language and the ecosystem of Elixir. It looks like that's all of them for now. And so I'd like to say thank you so much for having me here. I have some contact information up. And if you're interested in speaking more about the topics of nerves, Elixir, or philosophies in programming, please reach out to me. You can find me on Twitter, or you can also contact us over at Very Possible. And I look forward to seeing you all in person again sometime.